Viz 2320 Computing 2, and this is the first video in the series on finding and avoiding bugs. Okay, so this is a very simple overview. This is going to be all about bugs and how to avoid them. So first of all, a little bit of history. The term bug has been around in engineering for really quite a long time, and it's generally just a term used to describe having a fault. So I dug out a little bit of history. Apparently Thomas Edison, the inventor of the light bulb, referred to bugs as the little faults and difficulties, and that was in 1878. In the Second World War, people referred to bugs and glitches, used to describe problems in military hardware. Actually, the term glitch is quite interesting. It turns out that the origins of this are unknown, but has come out of work on radio and television, and generally means when you have a little spike in voltage or current that goes to make something going wrong. And you clearly understand in computers, if your computer has a little voltage spike, then something is not going to be very good with it. Of course, bugs are something not to be taken literally, normally at least, but there's this rather famous example from just after the Second World War, from the operations of the Harvard Mark II computers. This is right in the very earliest days of computing, and this records the discovery of a bug in the computer, and it was literally a bug in the computer that had got in and had caused one of the valves to blow, and thereby caused the computer to generate a fault. Anyway, if we want to think about bugs in code in modern computers, first of all, it's worth understanding why we get bugs, and it's very simple really. It's because people are fallible and computers are very, very stupid. They're also very, very fast, which means that any mistake you make tends to go wrong very, very, very quickly. Of course, that's not a great way of trying to avoid bugs, because people are always going to be fallible, so it's going to all be a way about figuring out how to avoid introducing bugs into code in the first place. So if one thinks about the different types of computer programming error you can make, the different kind of bugs you can have, then generally most people reckon they come in sort of three different sorts, which broadly you can think of as being things that are syntax errors. So that's simply mistyped statements, missing punctuation, brackets that don't match up, quotes that don't match up, and a particular Python one is when you have the wrong number of spaces at the start of a line. And I'll show you some examples of that sort of thing where that can happen in a little bit. There's then a whole class of bugs that are due to what you say identifier errors, and this can be things like mistyped variables and function names. It can also be simply where you use the wrong variable, so you didn't use the variable you thought you were trying to use. And again, in Python there's a particular class of these, which is when you fail to import a function before you try using it, and that obviously can give you a fault as well. The last sort, things that are actually the hardest to deal with and where you spend most of your life trying to avoid introducing them in the first place, are sort of logic and arithmetic errors. So this is where your code is syntactically fine, it uses the variables and the functions you think you're using, it just doesn't work because it's doing things in the wrong order, or you've got some invalid inputs, or you've made an assumption about what's going to happen that wasn't correct, a whole range of things like that. And it's these logic and arithmetic errors that are in fact the hardest things to sort out. So, first of all, if you do have bugs in code, what can you do to try and get rid of them? Well, the good news is that modern development environments, such as we're using in this course, do quite a bit to help you prevent at least finding syntax errors and identifier errors for you. So in Spider, you'll see a syntax error gets flagged up with a red error mark, and identifier errors come up with yellow warning sign marks. That doesn't necessarily mean that everything that's marked with a yellow is definitely a problem, and occasionally it fails to spot things and you have to go looking for them for yourself. And as I said, logic bugs are the things that are really much harder to find, and so we always work to try and avoid introducing them in the first place. And the videos I'm going to do after this one will do much more about trying to avoid putting logic bugs into your code in the first place. Okay, so let's take a look at some buggy code with some deliberate errors in it. Okay, so here we have a script which I've introduced a whole bunch of rather common errors. One of the things to point out about Python's error, about Spider's error finding, is that it will go through your script and it'll find the first thing it can. If it can get down and work out where there's a syntax error, it'll show those first. But sometimes, like here, you're going to get just a single warning error. And so you can hover over it and it'll tell you, in this case, you have an end of line whilst going for a string literal. So a string literal just means you've got a string which you start with a quote, and the problem, if you look at this, is saying it got to the end of the line and it hadn't found the end of the string. And that's because the string started with double quotes, but I was finishing it with a single quotes, and that's not going to work. You need to match your quotes up. Okay, so we can go and do that, and then Spider looks at the code again, and it says, oh no, we found another problem, and it's in fact come up with the same error. So this time, what you see, I've got double quotes there, I've got a double quotes there, but the problem is that if you have just a single double quote, you can't go and split the string over a line. So the only way you can have a string which includes a end of line in it is to make it a triple double quote. So we make it a triple double quote there. Now you see what's happened is it turned the whole thing into a string, which clearly I don't want either, until I match it up at this end. Okay, that's good. And now you see we've got our first syntax error. Unfortunately, syntax errors, it's not very helpful as to what the problem is. It just simply says invalid syntax. But this is actually quite a common one. This is getting the wrong equals sign. So one of the things you need to remember is that in Python, x equals 2 translates to set the variable x equal to the value 2. But what you want to do in a while loop is say, is x equal to 2? And the is x equal to 2 is a double equal sign. Okay, so it figures that one out, and now it comes on. Now here's a good example of where the error is not where you think it is. So it's come up and it said expected indented block. And you look at this code and think, oh, that's odd. I have an indented block. Maybe it's wanting me to indent down here. So you try and indent, and it still gets stuck there. You think, okay, no, that's not right. In fact, the problem is not this while loop. The problem is up on the top while loop here. And the problem is that a comment line, so with a starting with a hash sign, isn't any code. So as far as Python is concerned, this is a while statement with its colon, and then immediately afterwards the next line is actually going to execute is another while loop at the same indentation. So we need to put some code that's indented by, we normally use 4 spaces, or in Spider if you hit tab it inserts 4 spaces for you. We need to put a line in there. Now if you have a block like this and you in fact don't want it to do anything, you can just put the statement pass, and all pass means is Python's syntax says there has to be something here, and we want to just say, okay, that's fine, do nothing. So pass just means do nothing. Okay, so now in fact you see we have the same error here again, expected an indented block, and it's shown it up on this third while loop, but the problem is actually from this while loop here. So it's the same fix. It would pass in. Okay. Now we've got another rather common type of error, and this is saying us indentation or unindented does not match any other outer indentation level. So what's happened here? The problem is I've got 1, 2, 3, 4 spaces before my print line, but only 1, 2, 3 spaces before the pass. Probably what I meant here is to have 4 spaces. Oops. So I can put 4 spaces in and the error will go away. It might also be, however, that what I actually intended to go and do was to have it completely unindented. So the rule here you need to follow to avoid getting this sort of thing, and where you need to go and check, is to make sure that everything is exactly 4 spaces. If you use a text editor that's not aware that it's programming in Python, then when you hit tab, it might actually insert a tab character, which is different from 4 spaces or 8 spaces. It's actually a single character that means go forward to the next tab stop. And as far as Python is concerned, that just counts as 1 space. So this only happens if you use a text editor that's not aware that you're programming in Python and therefore doesn't know that when you hit tab what you really meant was give me a certain number of spaces. If you're using Spider, it'll get that right for you. The other thing to say in Spider is that if you hit Shift Tab, it completely unindents by 4 spaces, which can be quite handy. Okay, so now we've got another syntax error, and again it just says it's an invalid syntax. So this again is another really common example of a typical bug you managed to introduce, and what you're missing is the colon. So the rule here is that if you go from having a statement which then has an indented block after it, you're expecting to have a colon. So while colon and then the block, 4 is a colon. If you have if statements, so if I write a little if statement in here, if x equals 2, whoops, it's indented it for me too much. If x equals 2, colon, and then an indented block, like so. It's always, if you have an indented block, you always have a colon at the end of the line before. Okay, so now you see, it's fixed that syntax errors, and now it's done. No, there's a whole bunch of identifier errors. And these ones here, it's saying undefined name X. So what it's telling you is it's not sure whether or not you've passed in the value X. So what we could do is simply make sure we define X in the code. Obviously, in a real program, that will probably be a sign that you've failed to pass something in as a parameter into a function, or you've failed to import something correctly. There is something you need to be aware of. If you're importing things, so if I do from math import star, so the problem with doing this, well, there's a few problems with doing this. You see it's still flagging up a warning here, but now it's saying X may be undefined, or may be defined from where we imported the math module. So the problem when you do import star is now that Python has no idea, or at least, sorry, Spider has no idea what's in the math module by default. So it doesn't know whether X is in the math module or not in the X module, or not in the math module. So it can't work out whether or not that's a problem. That's one of the many reasons why it's quite dangerous to do from something import star. The other problem is that if you import 2 modules which have the same function name in them, then you're never going to be quite certain which version you're using. So a common example of this is that so math has a bunch of functions, like the trig functions, so sine, cos, tan, log, and so on. But also, whoops, failed to type. So does numpy. And so what you're going to have here, and you see it's actually telling us it's unable to detect whether you're actually using any of these functions. But numpy and math both have functions with the same name. Now in this case, what's going to happen is you're going to, from math import star, so you'll get math.sine and math.cos and math.tan will be imported as sine, cos, and tan. And then you do from numpy import star, and that will import sine, cos, and tan as well. So in fact, it'll just end up overwriting all the ones from math. So this is generally a very dangerous way of coding, because it's an easy way of introducing bugs, because you'll not be quite certain what functions you're using, and then if they actually do slightly different things but have the same name, then you can get very, very confused. So it's always much better to be explicit and import just the functions you actually need from the module, and then you know that you can see straight away that you're importing cos and sine there. So if you then do cos and sine, you know that you've clearly made a mistake, and in fact you can see that it's actually warning us here, helpfully, that we've redefined what cos and sine is. So that's a handy hint when you're doing your imports. So let's go back and make sure we set x equal to some value. So that now clears up all of those errors. So we still see we've got an error down here, and we've got errors up here. So if we look at the bottom one first, it's saying here undefined name sys, and the reason it's happening is because clearly I've just made a typo there. So syst imported but not used. So what I should have done is import sys, and that works out I've imported sys, but also I've used it, so it clears the error down the bottom here, and also the error on line 2. And then you'll see here it's telling us that OS is imported but unused, and math.cos and math.sine are imported but not used. Now, these are not actually problems that are going to stop your program from running. The program will run just fine. It doesn't matter that you've imported things and not used them. The only reason for warning you about it is that maybe you had intended to use them somewhere else, and you've imported them in the wrong place, or you've maybe mistyped a function name further on down in the code. So it's a way of spotting that there might be a problem. Generally speaking, it's not a good idea to import things you don't need, because all you're going to do is evaluate some code, some Python code when you run the program that you didn't need to. So it's cleaner just to make sure you import only the things you need. Okay, so now you can see we've in fact cleaned up all of the syntax and identifier errors that Spider had found for us. And I've also shown you how you can introduce some errors that maybe you didn't want to go and do. Of course, there's no question as to whether or not this code does anything that's actually useful or sensible. In fact, it's fairly obvious it must do nothing very useful at all, because we're setting this code x equal to 3, that while loop doesn't run, that while loop doesn't run, that while loop doesn't run, and this is simply going to print the same line 10 times over, and then it's going to exit. So in fact we can just prove that's what it does. There you go. It printed that line 10 times over, and then it says sys.exit, and it came out of it. And in fact, what's happened here is that IPython, the console in Spider here that I'm using, says it doesn't really like having sys.exit because you can't exit from Spider like that. So in fact that was a redundant line, we didn't need it at all. Okay, so that's just a very quick run through. Oh, and you see it now telling me I don't need sys either. Very quick run through of how Spider can help you avoid syntax and identifier errors. So that of course leads to logic bugs, and much of the next videos will be about ways of avoiding logic bugs. But there's some basic things we can go away straight away and talk about. So it's all really about thinking about how you're programming and trying to write it in a kind of fairly disciplined way that you can check and test each stage of the problem. It's exactly like if you're doing solving a big, long, complicated mechanics problem. You break it down into little sections that you can solve and check and get some interim results at each point. So you divide your program into small chunks. You make sure you know what each chunk is expecting as an input. You make sure you know what each chunk is expecting to give as an output. Ideally, you make each chunk a separate function, or maybe a separate module, and then you need to make sure that the whole thing hangs together. And really important is, it's often a really good idea to write things out in paper first, and then just check before you start going and coding on it. And then what you can do is you can check after you write each function that it does what you wrote down on the paper. And that's a good way of avoiding introducing logic bugs. What you write out on paper could be what we call pseudocode, so it's just a description of what each function does, but written out using the sort of same kind of words that you use in programming. So it's a rather kind of limited way of writing it, but you don't worry about whether you've got the right commas and brackets and quotes and everything else. It's just to get the basic structure of the program right. Or the other thing you can do is do a flow diagram, and that's actually part of the assessment on this module. And then of course you can test each chunk of code on its own, ideally, and that testing should involve trying inputs where you know what the answer should be, and also, quite importantly, trying inputs that you know are deliberately wrong or invalid, and making sure you understand what your code is going to do when it gets a bad result. And of course there's a whole bunch of things about making your life easier. So it's easier to keep track of what your program is doing if you've used sensible variable names, if the functions you write have names that at least roughly describe what it is they're trying to go and do. And that way it's much easier to work out what your code was supposed to be doing. So, in this first video, what I hope will convince you at least is that bugs are almost always inevitable. You've got these three types of bugs. So the syntax errors are simply your code doesn't follow the rules, and therefore it won't run. So in Python, what you want to be looking for particularly are things like missing colons, mismatched quotes, mismatched brackets, and also look for the wrong levels of indentation. So where you've indented some lines differently from other lines that should be at the same level of indentation. It's very easy to do that when you're moving lines in and out of indentation levels to accidentally end with one space out. There's then the whole class of identifier errors. So once you've checked for things like misnamed functions and variables and missing import statements, the other thing you can get is what I call variable scope mistakes. So this is something I talk about in the functions videos. So when you're using a variable inside a function, you need to make certain you know exactly where that variable is coming from. And it's very easy to go and get that wrong and have the wrong scope of the variable. And then finally, the big problems are the logic errors, and that's your code runs but doesn't do what you expected. And of course that tends to be the really common error that you tend to find. So in the next videos we'll talk more about how to avoid logic errors.